On problem 37, it says the rectangular coordinates of a point are given. In this case, it's 3, negative 3, square root 3. And it says find the polar coordinates in the form of radius, comma, the angle of this point with the angle in radians. Let r be greater than 0, and let the angle be between negative 2 pi and 2 pi. So first, let's plot this rectangular coordinate point on a Cartesian plane. So our x is positive and our y is negative. So that's quadrant 4. We go over 3 and down. That's approximately a little more than 5. So it'll be something like negative 3 square root 3. So that's what it looks like. And we need to find our radius to this point. So, of course, let's use Pythagorean theorem. R squared equals 3 squared plus negative 3 square root 3 squared. R equals the square root of basically that. And once you plug that into your calculator, you get out that R equals 6. So our R is positive, so we got that. Now we need to figure out our angle. So we can do tan inverse. So tan of our angle, let's call this angle alpha, equals our y over x. And our y is negative 3 square root 3. Our x is 3. So we can do alpha equals tan inverse of negative 3 square root 3 over 3. And when we do that, we get that, let me plug this in. We get that that angle is negative 60 degrees. So it's going from here. So basically, but what we need to actually find is, let me get a color to show up, the angle around here, which is theta. So what we can do is subtract 60 from 360, and that will get the rest of us. Because remember, circle is 360 degrees. So theta equals 360 minus 60 degrees, so theta equals 300 degrees. Now remember, theta had to be in radians, so let's convert it to radians. Okay, now simplify, and you should get 5 pi over 3. That angle is within our bounds of negative 2 pi to 2 pi, so that's good. So now let's just write it in polar coordinates. Remember, our radius was the 6, so it's 6, comma, our angle, and that's how you convert from polar to rectangular, that's how you convert from rectangular to polar.